So today I am going to be talking about arithmetic sequences. But before I can do that, we've really got to learn what an arithmetic sequence even is. And a widely used definition that's pretty simple is that an arithmetic sequence is simply just a sequence of numbers with a constant rate of change. And now I can give us an example to better understand this. So let's say that our sequence of numbers is, well, that's an eraser, oh my goodness, 3, 6, and 9, and that goes on forever. And now what we have to do is see the rate of change in between each number. From 3 to 6 is 3, and from 6 to 9 is also 3. And now this means that it has a constant rate of change, and it is in fact a sequence of numbers, making it an arithmetic sequence. And now this is all great. We can identify an arithmetic sequence, but how does this help us in real life? And well, the general idea is that it helps us understand patterns. And now an example of this is, let's say you're riding a taxi. You're going to be charged with the initial fee of opening the door, and then you're going to be charged per mile. This is an arithmetic sequence. And the next thing we need to know before we can do a sample problem is the formula. Okay, so the formula for an arithmetic sequence is a(n) equals, what the heck, a1 plus d times n minus 1. And so n in the equation is the number in the sequence that you're solving for. So you ride the taxi for 8 miles. That is going to be the number that you plug in. In this case, it would be equal to 8. Okay, and now a1 is simply just the first term in the sequence. So you open the door for $2.50 of the taxi, and then the first mile is also $1.50 because the first term is after 1 mile. That means that, going back to the taxi problem, the first term would have to be $4. But simply put, it is just the first term in the equation. Okay, and then d is just simply the rate of change. Again, going back to that taxi problem, we know that the change is just 1.5 because it increases by $1.5 every mile. So, rate of change, and then the n right here is just the same as the n in the beginning of the problem. And so this is the formula. Now, let's go do a sample problem. Okay, so we are going to find the 46th term of the arithmetic sequence 3, 8, 13, 18, and then going on. First things first, we need to identify the formula that we should use to solve this. And the only way that we know to solve for n is to use this formula right here. And then the next step would be to identify all of the known variables. We know that a1 is the first term in the sequence, and we look at the sequence and we see that 3 is the first term. So we write that a to the 1 is equal to 3. And then n is the number that we're trying to find, and we are trying to find 46, or the 46th term. So we would write 46 for n, and then d is the rate of change. And it's like, it doesn't tell us the rate of change. How are we supposed to find that out? Well, what I would do is subtract 3 from 8. And then when I do that, I get 5. We can double check that with the next number in the sequence. 8 plus 5 equals what? 13. So yes, we know that the rate of change is 5. Next thing we need to do is plug it into the equation. Okay, so once you have done that, it should look something like this. And if you haven't, you might want to double check your work. And now what we need to do is really just solve it like an algebra problem, as if we're solving for A46. So first what we need to do is just order of operations, which means that we have to do 46 minus 1, which equals 3 plus 5 times 45. Okay? And then the next step is to do multiplication. So then we have 3, and then plus, I used my calculator for this, 225, okay? And then 225 plus 3, well, that's just 228. And that means that A46 equals 228. And A46 is equal to the 46th term of the sequence. Answering our question. Thanks for watching. I hope this made sense.